Morning. Today we're going to look at the triangle inequality theorem and see how that applies to us today. So first we'll start with the triangle inequality theorem. It says that the sum of the lengths of any two sides of a triangle must be greater than the third side. The sum of the lengths of any two sides up here, must be greater than the third side. So in our situation, we recognize that a plus b, this a and this b, must be greater than this c. But it's also true for all of those sides. So a plus c, these two sides, must also be bigger than b. And finally, b plus c, these two sides, must also be bigger than a. Otherwise, a triangle doesn't exist. So, does a triangle with the sides 4, 5, and 7 exist? Let's take a look using the triangle inequality theorem. First off, is 4 plus 5 greater than 7? Well, clearly 4 plus 5 is 9. That's greater than 7, so that's a yes. You have to check all three sides though. Does 4 plus 7, is it also greater than 5? Of course it is. 11 is greater than 5. And is 5 plus 7 greater than 4? Well, 12 is definitely greater than 4. So, in fact, we do have a triangle here. A 4, 5, 7 triangle does exist. Let's try another triangle. Does a 2, 4, 7 triangle exist? Well, we'll do the same thing. We'll use the triangle inequality theorem. Well, is 2 plus 4 greater than 7? Well, 2 plus 4 is 6. 6 is definitely not greater than 7. Now, I can check the others and see that they are greater, but the reality is it doesn't matter. Once one fails, it all fails. And hopefully you can see by this picture that there's no possible way that a 2 over here and a 4 over here will ever meet together to make a triangle. They're just not long enough. So 2 plus 4 was not greater than 7. Let's try one more example. Does a triangle with the sides 1, 2, and 3 exist? Well, again, we'll use the triangle inequality theorem. Is 1 plus 2 greater than 3? Well, let's see. 1 plus 2 is actually equal to 3. Is that greater than? No. The answer is no. They are not greater than 3. So again, just like the previous example, it doesn't matter that the other two sides do work. We can see clearly that the 1 and the 2 will equal exactly a 3 right here, but if you were to lay those out, there would be no peak, there would be no point. They would be exactly the same length, and therefore no triangle exists. Here's another situation using the triangle inequality theorem. What if I know two of the sides, but I don't know the third side? What if a triangle with sides 4 and 6 does exist? What are the range of possibilities for the third side? So, I really have two situations here. I need to figure out the lowest possible number and the highest possible number. We'll start with the lowest possible number. I know that some number, x, plus 4, if some number is lower than that, together they must be greater than 6. Well, solving for x, I can see that x must be some number bigger than 2. On the other side of that, I can look for the highest possible number. In this situation, I know that my 4 and my 6 must be greater than whatever that biggest number is here. So that's pretty easy to see that 10 must be greater than x, or to flip that around, x must be less than 10. Therefore, I can see I have to be greater than 2, less than 10. In other words, the third side must be between 2 and 10. There's another relationship we want to look at with triangles, and that's the angle-side relationship in triangles. Simply put, the angle-side relationship in triangles tells us that the largest angle is always opposite the largest side. So in this situation, with 70 being the largest angle, the longest side would be AB on the other side. Similarly, the smallest angle will always be opposite of the smallest side. In our situation here, angle B is 50 degrees, so AC is the smallest side. If I wanted to rank the sides together, from largest to smallest, I could see that AB here is the longest side, BC, I didn't mention it, but clearly it's in the middle, and then AC is the smallest. Now, how does the angle-side relationship help us? Let's look at a situation. Fire tower A spots a forest fire 30 degrees north of east. Fire tower B spots the same fire 37 degrees north of west. Which tower is closest to the fire? Well, of course, first I need to draw a picture. So my picture may look something like this, where C is the forest fire. Looking at this, I can now use the angle-side relationship theorem, and I recognize that the largest side would have to be AB, and the smallest side would have to be opposite of that 30 degrees. Therefore, I know that BC is going to be opposite the smallest angle, and thus BC is the shortest side. Therefore, fire tower B will be closest to the fire. Thanks for joining in. Leave some comments if you need to.